So we're inside a fresh Unreal Engine project. Before we start building anything, let's quickly look at the interface and basic controls, especially if you're new. If you've used Unreal before, this will just be a quick refresher. First, if you see a message saying the project file is out of date, just click Update. Now, before doing anything else, go up to the top and hit Play to see what we're working with. What you're seeing is the default third-person template. Since we selected that option, this scene loads automatically along with this character. Click into the screen to take control, move your mouse to look around. If things seem a bit laggy, it's likely still loading. To move your character, use W, A, S, and D just like most PC games. Press the spacebar to jump. And that's it, you can run around and explore the level. You can bump into these cubes, they use physics, so they'll react when you hit them. This is your starting setup. Most of the core mechanics we need are already here, so feel free to explore for a bit. When you're ready, press Escape to exit and return to the editor. Now let's look at moving around the viewport. To control the camera, hold the right mouse button and move your mouse to look around. While holding it, use W, A, S, and D to move, just like in-game. The camera moves based on the direction you're facing. You can also move vertically. Press Q to go down and E to go up while holding the right mouse button. So your main controls are W, A, S, D, Q, and E. By default, you're in perspective view, which shows the world like the final game. But when building a level, it's often helpful to switch to straight views like top or side for better precision. To switch views, go to the top left corner where it says Perspective and click it. You'll see other options like top, side, and more. Select top to view the scene from above. When you do this, the view changes to wireframe mode by default. This makes it easier to see the structure of your level. You can switch it back to lit if you want to see how it looks in-game, but wireframe is usually more useful when building. There are also shortcut keys listed here for quick switching. For example, you can press Alt+G to return to perspective view. You can turn on wireframe at any time by changing the shading mode from lit to wireframe, even in perspective view, but it can look a bit messy there. In orthographic view, navigation is simple. Right-click and drag to move around and use the mouse wheel to zoom in and out. You can also zoom in using the mouse wheel in perspective view, though it's slower than moving with the keyboard. Now that you can navigate the scene, let's look at how to work with objects. Click any object to select it. Once selected, it highlights and shows a tool for moving it. To move an object, drag the arrows. Each one moves it along a single axis. If you drag from the corner between two arrows, you can move it across two directions at once. And if you drag the center point, you can move it freely in any direction. If you don't see this tool, press W to activate the Move tool. For rotation, press E. This brings up circular handles, just drag them to rotate the object. For scaling, press R. This lets you resize the object using the small square handles. So W for move, E for rotate, and R for scale. With the Scale tool, you can adjust size in different ways. Drag one of the outer squares to scale along a single axis. Use the corner handles to scale across two axes at the same time. And for uniform scaling, drag the center square to resize the object evenly in all directions. You might notice objects snapping or moving in steps. That's because grid snapping is enabled by default. Snapping keeps everything aligned to the world grid, which is useful for building clean, structured levels, so we'll mostly keep it on. But if you need finer control, you can turn it off. At the top, the highlighted buttons show snapping is active for movement, rotation, and scale. Click any of them to disable snapping for that setting. Once it's off, movement becomes smooth and free. You can also adjust the snap size. For example, position snapping is usually set to 10. If you increase it to 100, objects will jump in larger steps. The same idea applies to rotation and scale. Now let's quickly look at another panel, the outliner. Open it from here and pin it so it stays visible. If you do pin the panel, it will collapse back into the sidebar when you click in the scene. So go ahead and pin it to keep it open while you work. This panel is the outliner. It shows every object in your level. Select something in the scene and it highlights here, or click an item here to select it in the world. You can also customize your layout. Right-click the Outliner tab and choose Undock from sidebar to keep it open permanently. From there, you can drag it out into a floating window, move it anywhere, or dock it to another part of the screen. I'll keep the default layout since that's what I prefer, so I'll just dock everything back into the right sidebar. Next is the Details panel. Once pinned, it stays open. This panel shows all the properties of whatever you select in the scene. Let's click this large large cube, you'll see it's a static mesh. Static means it isn't rigged or animated, it doesn't deform. It stays exactly as it is in the level. Most environment objects and props are static meshes. In the Details panel, you'll see two key things, the mesh itself and its material. The mesh defines the shape, while the material controls how it looks. For example, under Materials, Element 0 is the active material slot. Since this cube only has one, that's all we see. From the drop-down, we can swap it to another material, like the prototype grid. The appearance changes, but the actual shape stays the same. And if you want to remove an object, it's just as simple. To delete an object, just select it and press Delete on your keyboard. To add new objects, open the Place Actors panel. You can resize any docked window, even when it's pinned to the sidebar. The Place Actors panel contains basic building blocks you can drop into your level. Under Shapes, for example, you can drag in a cube directly into the scene. Now we have a new object placed. This is often used for quick prototyping, especially for things like lights or simple layouts. Most of the time, final environments use proper assets instead of primitives, but these are perfect for blocking out ideas. Let's delete that object and move on. Next is one of the most important panels in Unreal, the Content Browser. We'll dock it for now so it stays open. The Content Browser shows all the assets available in your project. Unlike the outliner, it doesn't show what's in the level, it shows what you can use to build with. In a third-person template, you'll see folders like Characters, Level Prototyping, and Third Person. These are your project's core building blocks. How you organize your folders is up to you, just stay consistent. Personally, I like to separate the default template content from anything I create for the game. To do that, I'll make a new folder inside the content directory. Everything in Unreal must live under content. If it's outside of it, it won't show up or work properly. So make sure you're always working inside this folder. Right-click in the empty space, create a new folder, and name it a template. Now we have a clean folder under content. You can open it with a double click like normal. From here, I'll move all the default template assets into this folder to keep things organized and separate from new content I add later. Now let's take the Characters folder and drag it into our template folder. When prompted, choose Move here. Depending on how much content there is, this may take a moment, similar to moving files on your computer. Once it's done, the folder appears inside Template and all the assets are still there. But you might notice something strange, the original folder still shows up outside. That's a quirk of Unreal's folder system. Sometimes the view doesn't update cleanly after moving content. If you open those old folders, you'll see they're actually empty now. So even though the folders still appear, the assets have already been moved. Because of how Unreal handles its content hierarchy, these empty folders can sometimes be tricky to remove. To properly remove them, first hit Save All. Then in the Content Browser, right-click and choose Fix Up Redirectors in Folder. After that, try deleting the empty Characters folder again and confirm. Sometimes Unreal struggles to remove folders, especially when working with default template content. If that happens, there's a manual fix. Close the editor and save everything. Now go to your project folder in File Explorer. Open the Unreal project directory, then go into the Content folder. Here you'll find the Characters folder we were trying to remove. You can delete it directly from here. Now reopen the project, and the empty folder should be completely gone from the Content Browser. You can go into Template Characters and see that the actual files are still there under the template folder. This is just one of those quirks of Unreal's file structure, so staying organized is important, but expect some odd behavior sometimes. I'll go ahead and move things again. Some folders move cleanly, but others can fail due to references or dependencies. When that happens, use Fix Up Redirectors first. In many cases, that solves the issue and lets you delete or move assets properly. If it still doesn't work, you may need to remove them manually from the project directory. Now that everything is organized under a clean structure, let's look at the actual content. Any asset you import or create in Unreal shows up here in the Content Browser. To open an asset, just double-click it. Let's go into Third-Person Blueprints and open the Third-Person Character Blueprint. This opens a separate blueprint editor window. Blueprints are Unreal's visual scripting system. They let developers build gameplay logic without writing traditional code. Let's break down this character blueprint. On the left, you'll see the Components panel. This shows all the parts that make up the character. To understand it better, switch from the Event Graph to the Viewport tab. This shows how the blueprint looks inside the editor. Not everything you see here is visible in-game. For example, the capsule component is just a collision boundary around the character. It helps with physics and movement, but you don't actually see it when playing. There's also an arrow component, used to define direction and placement. The mesh is the actual character model, and the camera component controls how the camera follows the player. If we click the mesh, the details panel updates on the right. This panel shows all settings for whatever component is currently selected. All of this information applies to the selected mesh, not the entire character. In the details panel, you'll see options like materials, the mesh itself, collision settings, and more. We'll go deeper into these later. Next, let's switch to the Event Graph tab, the same one that was open when we first opened this blueprint. This is where the actual gameplay logic lives. It controls how the character moves and behaves. Instead of writing code, Unreal uses nodes. For example, look at the movement input node. It triggers when a key is pressed, like W for moving forward by default. That line is the execution flow. When input is received, it sends a signal to whatever is connected next. From there, the movement component calculates direction and applies the movement based on that input. We won't break down each node in detail yet. We'll cover that later when we get deeper into blueprints. For now, just focus on how everything looks and connects. This is your actual gameplay logic. The last tab is the construction script. It looks similar to the event graph, but it works differently. Anything you add here runs in the editor, not when the game is playing. For example, you can use it to change things like materials dynamically while you're building. I'll quickly demonstrate this. Don't worry about following along step by step. I'm just creating a simple new material so you can see how it works. In the construction script, I can drag in a reference and set the material directly on the mesh. This lets you see changes instantly inside the editor before you even press play. By dragging out and searching for set material, I can add that node and assign a new material. I'll switch it to a clean version. Right now, nothing looks different in edit mode. If I press play, the character still uses the default gray material. Now I'll drag another instance of this third-person character blueprint into the level so we can see the difference. To do that, I just drag it from the content browser into the scene. Now there are two characters in the level. When I press play, I'll see another character added to the scene as well. The key point is this: using the construction script, I can change the material per instance. That means each placed character can have its own unique look. So in the details panel, under the default settings, I can now switch the material for just this instance. And because it's instance-based, it doesn't affect the character I'm controlling in-game. So when I press play, my controlled character stays default, while the placed one uses the new material. This is what makes blueprints powerful. You can reuse one system and customize each instance. Typically, you create one master blueprint and place copies in the level, then adjust variables as needed. We'll eventually replace this default character with our own custom one later in the course. But first, there are a few things I want to adjust in this base setup. When I change a character instance like this, it doesn't affect the default version I'm controlling in play mode. So I still keep the original gray material when I press play. If I want every version of the character, including the playable one, to always use a different material, I need to change it inside the blueprint itself. So I'll set it to the new material, then hit compile to make sure there are no errors. After that, press save, return to the level, and press play. Now the character uses the new pink material. Before we move on, there are a few defaults I want to adjust. I don't want to use this mesh as is. Unreal includes a few alternative character meshes like male and female mannequins, so you can switch based on your project needs. In my case, I'm using a male character, so I'll change the mesh to the male mannequin. In the details panel under mesh, open the dropdown and switch it to the male mannequin option. I'll also remove the temporary setup we used for demonstration. Quick note, if something looks off or doesn't update correctly, just close and reopen the blueprint. That usually fixes simple display issues. Now everything is reset and ready for the next step. So that's how you change the character mesh using this option here. Eventually, we'll replace this with our own custom mesh imported into Unreal, but the process will stay the same. Next, I want to adjust the movement. While testing the level, I felt the character movement was a bit too slow and sluggish. We can fix that inside the third-person character blueprint. Go back into it, and anything related to movement is handled by the character movement component. Select it, and you'll see the details panel update. One of the key settings here is max walk speed. Right now, it's set to 500 centimeters per second. I'll increase it to 750 to make the character run a bit faster. Unreal uses centimeters by default, so this value directly controls speed in cm per second. Now hit compile to check for errors, then save. You'll usually see a yellow icon when changes need compiling, a green check when everything is correct, and a red X if there's an error. Once everything is good, return to the level and press play. Now the character feels noticeably faster and more responsive, without being overpowered. You can tweak these values as much as you want, make the character super fast or really slow. Most of them are fairly self-explanatory, and the best way to learn is simply to change a value and see what happens. If you want to reset anything back to default, you can click the small reset arrow next to the setting. Just note that not all defaults are actually true defaults. Some values are already modified in the template. For example, gravity scale here is set to 1.75 by the Unreal template itself. If you reset it, it goes back to 1. That immediately changes gameplay. Your jumps become very floaty and unrealistic. So I'll set it back to 1.75, compile, save, and return to the level. Now the jump feels normal again. And that's it for tweaking the third-person character blueprint. We'll go much deeper into blueprints later in the course. If this felt a bit confusing, don't worry. Just remember the basics. You can change the character mesh here, adjust materials here, and we'll go deeper into materials later. For now, don't stress about creating anything complex. The most important part at this stage is movement. In the character movement section, we've only changed two things: max walk speed set to 750 and the mesh switched to the mannequin. That's it. So this wraps up a quick overview of the interface, navigation, and the character blueprint. In the next part, we'll start building and prototyping our own custom level.